All right, so start from today, we'll learn chapter 7, okay? And from chapter 7, we're going to learn the first several sections, okay? You will see all of these sections, they tell us what? Different kinds of the techniques or skills about how to do integration, okay? Integration, okay? So this section 7.1, okay? This is a first section in chapter 7. We talk about integration by parts. This is a method, okay, help us to do integration, okay? This is very important, okay? A lot of the integration questions, we're not able to find as antiderivative directly, or we may not be able to use a substitution to do the problem. Then we have to think about some other method to, to do the integration, okay? So this method is telling us, oh, integration by parts helps us to do the integration question. Okay, all right, let's look at the idea about the integration by parts. Okay, so I'm going to ask a volunteer to read. It's kind of challenging for you, okay? This paragraph for us, including all of these formulas, okay? Who want to read? Any brave volunteer to read this? Okay, Amanda? Mm-hmm.
Now, if we take antiderivative on both sides of the equation, we get the integral of f of x multiplied by g prime gx prime dx is equivalent to the integral of f prime of x multiplied by g of x dx plus the integral of f of x multiplied by g prime of x dx. F of x multiplied by g of x is equivalent to the integral of f prime of x multiplied by g of x dx plus the integral of f of x multiplied by g prime of x dx. Then we have the integral of f of x multiplied by g prime of x dx is equivalent to f of x multiplied by g of x minus the integral of f prime of x multiplied by g of x dx.
Mm-hmm.
This is so called integration by parts, which is a technique to integrate the product of two functions.
Very good. Thank you so much. Okay, so Amanda just read, this whole paragraph. Now I'm going to explain to you more in details. Okay, in details. All right, so you may wonder, oh, what are these, like lines of the formulas? Okay, so let's talk about these, lines. Okay, all right, so we know that for product rule, okay, if we have a function, product of two functions, f and g, okay, the derivative of the product equals what? We differentiate one of the function, okay, and then times by the other, okay? So f times g prime equals f prime times g plus f times g prime. Everybody know this, right? This is a product rule. Okay, now what we're gonna do is we're gonna integrate both sides. Okay, yeah, for this equation, we're gonna integrate from both sides. Left hand side, we'll have an integral of the f times g's derivative. Okay, right, well, we have dx, this is together with the integral symbol, okay? And right side is gonna give us what? Integral of f prime times g dx plus integral of f times g prime dx. Okay, this step is just simply take antiderivative or integrate both sides from the previous equation. Now let's see, left hand side. We know derivative and integral are a pair of inverse action, right? So take derivative, then we integrate. These two actions offset because it's a pair of inverse action, right? So that's why we're not having derivative anymore. We're not having integral anymore. We're having just f times by g. Guys, do you see how from here to here we get here, right? Derivative and integral offset. So we have f times g, no derivative, no integral anymore. Right side, it is still the integral of f prime times g plus integral of f times g prime. okay? All right, now from this equation, okay, in order to isolate this term, the integral, you see that? Okay, these two are the same, okay? In order to find the integral of f times by g prime dx, we're gonna subtract the integral of f prime of x times g from both sides. We subtract this term, or we move this term to the other side. Okay, we move this term to the other side. So that's how we get what? F times g minus the integral of what? F prime times by g dx. Guys, do you see how we get derived until this line? Okay, this line. All right, so this formula we call, it is what? The formula for integration by parts. Okay, this is a formula. Okay, this is a formula for integration by parts. Okay, if we look at the formula, you will see, okay, this formula is telling us if we want to come to the integral of a function f times by g prime dx, we can, you know, as long as we know f, and then we find the antiderivative of g prime, which is g, this integral will becomes f times g minus the integral of what? Derivative of f times by g dx. Okay, yeah, so see, for a given integration question, okay, integral question, okay, in order to use integration by parts, we have to know what is a function f, what is a function for g prime. Okay, so once we know what is f, what is g prime, we can integrate g prime to get g. We can differentiate f to get f prime. Then we will be able to use this formula to do calculations, okay? All right, so this is a formula, but we don't use this formula very often, okay? What is a easier way to remember the integration by parts? Actually, this is something that I want you guys to pay more attention, okay? I'm gonna ask another volunteer to read this 3-line, including this line, okay? Yeah, 4-line short paragraph for us, okay? Anyone from the online class? Anyone read? Nobody? I'm gonna call some of you guys, okay? Okay, Dominic?
Yes, I can.
Yes.
It is perhaps easier to remember in the following notation that u equals f of x and v equals g of x. Then the differentials are du equals f prime of x dx and dv equals g prime x dx. So by the substitution rule, the formula for integration by parts becomes the integral of u dv equals uv minus the integral of v du.
Okay, very good. Thank you so much. Okay, so Dominic was reading. Okay, I'm gonna repeat this for us. Okay, for us. This is something that later when we mention integration by parts, you have to be very familiar with this formula, okay? What does this formula say, okay? Because this is so hard to remember. What we can do is we use substitution, okay? We're going to let f of x equals u, okay? We're gonna let it v equals g of x, or g of x equals v, okay? So from this substitution, we know, if we differentiate both sides from this equation, we can get du equals what? F prime dx, right? If v equals g of x, we know dv will equal g prime of x dx. All right, so we're gonna use substitutions to rewrite this formula for integration by parts. So left-hand side, what can we get, guys? To replace f of x, we can get what? U, right? Do you see that? Okay. What is g prime of x dx? dv, okay? So the left-hand side becomes u times by dv equals f is u, g is v. So f times g becomes u times v here, right? Minus integral of what? G is what? V. We have an f prime of x times dx. What is it? du. Okay, so we're kind of, just using the, substitution to rewrite this formula. So that gave us this conclusion, okay? The integral of u times dv equals uv minus integral of v times du. You'd better remember this formula, okay? Well, of course, you can write it down on your formula sheet. But if you just write on your formula sheet without enough practice, that's not enough, okay? So I want you guys to really remember, this in your mind. Okay, so every time when you do the question, oh, once we find a u, once we have the, the rest will be dv, okay, and then we're going to use this formula directly to do the calculations. Okay, so this is formula I want you guys to remember. This is the same thing, okay, but if you want to remember this, memorize this one, it's fine. Okay, you can see they are the same formula but different notation. Okay, yeah, this one looks simpler because we use a substitution rule. Okay, substitution rule. All right, so we are going to do calculations, okay? You see, for the entire section 7.1, okay, these are the only two new things for us, okay? These are only new things for us. This is integration by parts formula. Everything else are just what? Practice, practice, practice. Okay, there's nothing new, okay, for this section. Okay, just make sure that we understand these two formulas right now, and then entire class we keep on practicing, okay? Keep on practicing. All right, so before we look at the practice question, okay, there is a guideline for us to, to compute integrals by integration by parts. You may ask, oh, for a given function, say for example, if we want to integrate f times sin of s dx, there are two functions, okay? We can see an x, right? We can also see a sin of x. Which function do you want us to be, which function do you want us to be u or f of x? And then left over function will be the g prime or dv, okay? So how can we choose the f? How can we choose the u? This is something that I want you guys to have a brief idea about. Oh, when we encounter a function, okay? So how can we choose u? And then the leftover will be dv, right? All right, so I'm gonna ask a volunteer to read the guideline, okay, this paragraph, okay? And then we will, after we understand this part, and we'll start to practice, okay? Who want to read this guideline? John?
Guidelines for integration by parts. If we are given the indefinite integral in the form of the integral of x sine
X.
dx, how do we know if x is f of x and sine of x is g prime of x, or x is g prime of x and sine x is f of x? There's a strategy for choosing f of x and g prime of x. When the integrand is a product of two functions from different categories on the list, logarithm, inverse, trigonomic, algebraic, trigonomic, exponential, while the function whose category occurs earlier in the list will be f of x and later will be g of x prime, or g prime of x.
Very good, thank you, okay? So this is kind of hard to remember, right? So, okay, we have two functions. Which one is f, which one is g prime? Okay, it's hard to choose, okay? But just remember one thing, okay? Just remember one thing. Because see, u and dv are the two functions. Eventually, in the formula, we have to compute what? du, okay? We're gonna differentiate the u, okay? We're f, okay? We're differentiate f. And then from the dv, we will find an integral of dv, we'll get a v here, okay? So our aim to use integration by parts is, after we differentiate the u, okay, we will get a new integral, okay? We want this new integral is simpler, okay? Hopefully simpler, will not become more complicated than the original integral, okay? So that's our aim. So when we, how to choose the u, or how to choose the f, okay? So you're gonna try x compared with sin of x. Which function, when we differentiate it, we get a simpler function. When we differentiate x, what do we get?
1.
1, right? 1 is simpler than x, right? Because 1 is a constant. How about x? If we choose sin of x to be our f, when we differentiate a sin of x, what do we get? Cosine of x. Cosine x and x, they are the same level of the trig function. They're not saying one is easier than the other, right? So for this question, if you're going to choose f and g prime, or u and dv, which function do you want it to be our f? We want the x to be our u, or f, right? So I'm going to write this thing, I'm going to write it here, okay? So we're going to let you can also write this on the, space, empty space, and then we're going to solve this problem, okay? We're going to let u equals what? X, where function f equals x, okay? And then all of the rest will be our dv, okay? So once we choose f for u, all of the rest will be dv, okay? So dv equals what? Sin of x dx. All right. Now you see later, oh, we need to know what is u, what is v. Do we know v? No. So, but how can I find v? If dv equals sin of x dx, v will be what? The antiderivative of sin of x, right? What is antiderivative for sin of x? Cosine? Or negative cosine? Yes, negative cosine. Oh, okay, so we know u is x, we know v is negative cosine x. And also we need to compute this integral of v, we know v, times by du, right? So we're gonna differentiate what? The u, right? So du becomes what? Dx, okay? U equals x, so du equals dx. Okay, so that means once we figure out what is a u, what is a dv, differentiate u, and also integrate dv. Always like this. You're going to practice a lot today, okay? You'll see. It's always like that. And then let's apply the integration by parts to solve the problem. Okay, so now we know this is integral of u times by dv. It should equal what? U times v. What is u? X. Times by v. What is v? Negative cosine x. So this will be u times v, which is this, right? Minus what? Integral of v times du. What is v? Negative cosine x. Okay. Oh, negative cosine x times by du. What is du? Dx. All right. Negative become positive, right? So this line is, oh, negative x cosine x plus integral of cosine x dx. Do you know what is antiderivative for cosine? You do, right? So you should have a negative x cosine x. Tell me, please, cosine x antiderivative. What is it? Nobody knows? Say it. All right, here, add a constant c. We get rid of the indefinite integral, add a constant c. Done. Do you have a brief idea about this question? How we choose a u? Left over will be what? dv. Integrate, differentiate u. Integrate dv give us v by formula. U times v minus integral of v times by du. Right, guys? Yeah, so this is a general idea, like in general, how to choose f, okay, how to choose u. Oh, use u. When we differentiate it, it is what? Make the derivative easier than before, okay? Yeah, because when u equals x, du should be equals what? What's the derivative of x? 1 times by dx, right? Okay, and then they also in the guideline, it tells us, okay, if we have a product of the two functions, okay, one is logarithm, The other one is, say, for example, exponential. Well, one is logarithm. The other is like inverse trig, something. We always choose what? The function who are what? Yeah, the earlier from the list. We want to choose them what? As the f, okay? Because logarithm function is easy to do the, derivative. Ln x, what is the derivative for Ln x? 1 over x, right? So we don't have log anymore, okay? And then for inverse trig, okay, so inverse same, what is the derivative? You can see it's 1 over square root of 1 minus x squared, something like that, okay? I may be wrong, or maybe I maybe remember wrong, but this is some guideline for you to think about, okay? However, you don't have to remember this, okay? You just need to remember, oh, for a product of two functions, think about which function when we differentiate that give us an easier derivative. Give that a try at the first, okay? If it doesn't work, try the other function to be RU, okay? To be RU. Okay, are you guys ready to practice? There's nothing new, okay? Just like, all of the rest of the class are just practice, practice, okay? All right, so question A. Evaluate integral of ln x dx. You see two functions? There's just one. So what do we do? Just let the given one function to be our u. And then the leftover, what is the leftover? Dx, that's our dv, okay? So we're gonna let u equals what? Ln x. If this is u, the leftover will be what? dv, okay? So dv equals what? dx. What do we do now, guys? How do we deal with the u equals ln x? What do we do? What kind of action should we do?
Differentiate.
Yes. So we're gonna differentiate both sides. So du equals, how about you guys tell me? Du equals what? 1 over x dx, okay, because it's differentials from both sides. Make sure that if we have du, right side, it has to be something times by dx, okay? And then this is a, differentials. After we integrate, there will be no differential from, from this here, okay? So if dv equals dx, how about v? This is kind of 1, right? What is the antiderivative for 1 in terms of x? X. dv equals dx, so v equals x. You can check. Differentiate v from both sides. Differentiate from both sides. Left hand side we have dv, right side we have what? dx, right? Now what do we do from here? Integration by parts. Remember the formula. U times v minus integral of v times du, okay? So u times v, these two, okay. U times v, okay, so we should have a x times by ln x minus integral of v times by du, these two, okay, these two. So we have x times by 1 over x times by dx, right? Multiply these two. X times 1 by 1 over x dx. What is x times 1 over x? What is it? 1. So x ln x minus what? 1, and the derivative is what in terms of x? X, right? Plus what? Constant c. You guys, first good? Question A. All right, so let's try question B together. We're gonna find the integral of x times by ln x dx. There are two functions, one is x, the other one is ln x. Which function do you want to choose it to be our u? Okay, so let's give it a try. Let's see whether it works or not. Okay, so if we let u equals x, so the dv will be what? ln x dx. We have to make sure that we're able to find du. Also, we have to make sure that we're able to integrate dv. So yes, du equals dx, no problem. What is antiderivative for ln x? Is it 1 over x? No. The derivative for ln x is 1 over x, but we're not computing the antiderivative. So are we able to, what is antiderivative for ln x? We don't know, but if we know, it's going to be complicated than ln x. So can we choose this option? No. See, here, when logarithm combined with algebraic, I would assume that this algebraic is the polynomial something, okay, polynomial. We would choose log for our x. We're going to more likely, okay, to choose. But it really depends, okay, it depends. But see, for this question, if we let u equals x, dv equals ln x dx, we're not able to keep on doing the question, right? So switch, okay? So sometimes, you know, if one way doesn't work, we have to try the other way, okay? What's the other way? Just let u equals ln x. And then the leftover are what is what? X dx, right? dv equals x dx. So what do we do now? Differentiate u 1 over x dx. Integrated x. What is antiderivative for x? 1/2 x squared, right? So far so good. Now let's see whether we can do the question or not. Okay, let's see. All right, so this equals integration by parts. U times v, multiply these two, 1/2 x squared x minus integral of what? V times by what? du. Okay, v times by du. Okay, so give us 1/2 x squared times by what? 1 over x dx. All right, so let's simplify. 1/2 x squared ln x minus square and this x cancel out. This is actually 1/2 x, right? And the derivative for 1/2 x should be what? 1/4 x to the square, right? Agree with that? Because for x, and the derivative is 1/2 x squared. 1/2 x squared times by 1/2. 1/4, right? Done. Everybody in class clear about this question, how we do the question? All right, can we move on? All right, let's move on to the next page. Okay, yeah, later I'm gonna let you practice some questions, okay? I'll lead you to do some and I will let you practice. Question C, let's talk about it and you're gonna try it by yourself. X to the 4th power ln x dx. Which function do you want it to be our u? Yes, because see, if you let u equals x to the 4th power, this will become dv. We have to integrate ln x. We still don't know that, right? So let u equals ln x, dv equals what? X to the 4th power dx. So try this question later in group, okay? Yeah, okay. So this is something I want you guys to practice later, okay? So I'm gonna, you know, lead you to do some question, okay? So question E, guys. Question E. We'll talk about D very soon, okay? When we talk about the trig functions, we'll talk about D, okay? But now I have to say that let's you know, we'll talk about everything involving ln x, okay? E. ln x square dx. How can we let our u equals? Just Lnx squared, right? No choice. Let u equals Lnx squared. You may ask, oh, this is Lnx squared, so we can consider this Lnx times by Lnx. So can we let just one Lnx to be u and the other Lnx dx to be dv? No, you know that Lnx dx we cannot integrate Lnx, right? So here we have to let the Lnx squared as our u, and then the leftover to be our dv, okay? So u equals Lnx squared, dv equals what? dx. Okay, so this one, okay, let me think. What differentiate this? Yeah, you can do this. You can also do this one by yourself, okay? So just follow the integration by parts, okay, okay? You can also try this one by yourself in group, okay? All right, so all of these questions, we talk about the involving what? Lnx. And you can see that, what kind of, you know, like the way that you think, when we involving Lnx in the integral, what should we do most of the time? We let u equals Lnx, okay? So that's what we see. It is also the rule here. See, logarithm is the first place, okay? Is in the first place of this list, okay? So that means from our, you know, like practice, our experience, oh, we find once an Ln shows up, most of the time, okay, I'm not saying I'm 100%, okay, most of the time, every question depends, okay, most of the time, we let Lnx to be our u, okay, log, okay, natural logarithm to be our u, okay. All right, so this question involving the natural logarithm, okay. Now let's talk about something involving exponential, okay, involving exponential. We're having question F and G, okay, involving the exponential. See, this question is x times e to the x dx. This question is x squared times e to the x dx, okay? So let's, you know, try them one by one, okay? So x times e to the x dx, which function do you want it to be our u? X. Why? Because, you know, if we let e to the x to be our u, when we differentiate e to the x, we'll still get e to the x. It doesn't make it simpler, okay? And then when we integrate x, if we let x to be our g prime, okay, or v, okay, dv, it becomes more complicated. So that's what we don't want to see. So we're gonna let u equals x, dv equals e to the x dx. All right, let's see. Differentiate u give us what? dx, and v equals what? E to the x, right? You guys? Now what we can have is what? U times v, x times e to the x, minus integral of what? V times du. Oh, we like this. Haha. There's no x times e to the x anymore. It becomes e to the x itself. See, this integral looks simpler than the original one, right? You have to know that the idea for us to using the integration by parts is, after we use integration by parts, this integral cannot be more complicated than the previous one. If your integral become more complicated, you have to switch or rethink about it. Because we want to have a simpler integral in order to find the entire, you know, integration, right? Yeah, integral, okay. All right, so what do you have eventually for your result, guys? X e to the x minus what? E to the x plus what? C. Done. Everyone? Similarly, question G. If we have a polynomial which is a power times by e to the x dx, which function do you want to choose to be our u? E to the x or x squared? If we let u is e to the x, differentiate doesn't make derivative simpler. And we have to integrate x squared and become more complicated. So still gonna use that u equals what? X squared, right? And then dv equals what? E to the x, okay, dx, okay? This question, I will leave it for you to try in your group, okay? Just differentiate du, integrate e to the x, you still get e to the x, and then by using integration by parts to do the problem. Now, my question for you is, when we are involving a polynomial, okay, which is, this is like a monomial, okay, just one term, polynomial, times by exponential function. Most of the time, okay, or if I'm giving you another problem, the compute integral of x to the cube times by e to the x. Which function do you want to choose to be our u for most of the case? For this type of the question. Can you guess? Most of the case, we're going to let u to be our polynomial. We leave the exponential to be dv, okay? So if we go back to the list, you will see, guys, here, logarithm, just now we know, very easy, u, right? We are u. How about our exponential? Put it in the last, okay? See, when exponential encounter what? Polynomial. Polynomial is more likely to be our what? F or u, okay? See, how to find a u? It says here, okay? Function whose category occurs earlier in the list will be u. The later will be what? dv. See, just now when we encounter x times by e to the x, we let u equals what? X. Remember, right? See, oh, log. Good candidate for you. Exponential, not good candidate for you, right? Okay, all right, so that question, okay, you will have time today in class, okay, to do this G later. Okay, once you find out what is U, what is dV, just repeat the integration by parts, okay? So that's good for these two, two questions, F and G. Okay, all right, now we look at what? Questions involving what? Trig. I know you don't like trig, okay? I don't, yeah, you guys don't like the trig functions because, trig functions, the differentiation, integration, and we have to be careful, okay? So this question D, this question H, and I, okay? Yeah, H and I are more similar because H is an exponential times by trig. Exponential times by trig. They are the same thing, but just, for the powers of E and also the coefficient of theta, they're different. But you will see later, these two questions are very similar, okay? Very similar, okay? All right, so when we have a polynomial times by trig, which function do you want to be our U? Just now we talk about, if we let u equals the trig function, when we differentiate, we'll still get the same function, right? Same function is the same level, what? Easier, right? Same hardware, easier, type of the function. However, if we let u equals x, dx give us what? Du give us what? Du, right? Du gives that dx. So derivative of x is 1, is simpler. And then when we integrate this cosine, we still get the same. So we're gonna let u equals what? X, and dv equals what? Cosine of 5x dx, okay? So cosine of 5x dx is dv, this is u, right? Okay, so when power function, when algebra, together with a trig, which one do we consider to be our u? Power function, okay? We're polynomials, we're algebraic, okay? So that's why here, guys, you see on the list, okay, when we encounter, yeah, I don't know why they, they give us algebraic. I would say this is polynomial, most of the cases it's a polynomial. So when we encounter polynomial and the trig function, we very likely, okay, most of the case we let the polynomial to be our u, and then the trig function to be our what? dv. Okay. All right. So let's still do the question together. Okay. Yeah. All right. So u equals x and dv equals cosine 5x dx. So let's do it. Okay. Let's do it. So du becomes what? dx. How about v? What is the antiderivative for cosine 5x dx? Equals negative sine 5x. Done. Cosine 5x is different from cosine x. So if we're having cosine 5x here, I'm going to tell you a shortcut to do the problem. Cosine 5x. Okay. We're going to multiply by a 5 here. This becomes d of 5x. But if we multiply 5 here, we're going to have a what? 1/5 in front. So cosine of 5x, d of 5x, and the derivative will become what? Positive or negative? What is the antiderivative for cosine? If you forget, have a formula in front of you, okay? Cosine 5x, d of 5x, and the derivative is sin of 5x. Okay, same, positive same. Because think about it, derivative of sin function is cosine, right? So positive sin of 5x. But don't forget there's a 1/5 there, right? 1/5. So and the derivative will be 1/5 sin of 5x. Okay. All right, so here, the antiderivative for cosine 5x is what? 1/5 sin of what? 5x. Agree with this, everybody? All right, now let's see what we can get by integration by parts. U times v. Okay, 1/5 times x times sin of 5x. Okay, minus what? Integral of v times by du. Okay, v is 1/5. I read as 1/5 in front. Sin of 5x dx. You guys, right? So our aim is to find what is antiderivative for sin of 5x, right? This is our aim, okay? So I would say, keep on writing this 1/5 x sin of 5x, okay? Minus 1/5, this is what we copy from here, okay? What is antiderivative for sin 5x? We do the same thing there. Multiply 5 to x, do a 1/5, right? So antiderivative for sin of 5x d 5x. What is antiderivative for sin? Negative 1/5 cosine 5x. You agree with this? Okay, so here, minus negative 1/5, and then times by another what? Negative 1/5 cosine 5x. Okay, and then don't forget to add our constant one, c here. Okay, so negative 1/5 times negative 1/5, this actually become what? Positive 1/25. Okay, so answer is these two together give us plus. I don't want to rewrite another line. You can rewrite it by another line, okay? So answer is 1/5 x times by sin of 5x plus, okay, yeah, plus 1/25 times by cosine 5x, and then plus a constant c. Is this question challenging? No? Okay, I hope to see that, okay, it's not that challenging, okay? Yeah, see? We let x to be u, and then left over to be dv, okay? Yeah, so compare with the polynomial. Trig is not, yeah, trig is not a good candidate for u compared with polynomial, okay? All right, so can we move on to the most hardest question, I would say? Oh, when we encounter the trig and exponential, look at these two. Trig and exponential. Both of them, they're not good candidates compared with some other functions, right? So what should we do? Exponential, always put it on the last, right? It's the last candidate. So when we have trig, what should we do? We're going to let the trig function to be our what? U, okay? Well, actually, you will see, if you let e to the x to be u, it also works. It also works. You can try. But in class, I just want to let you know that, okay? Since we're having this guideline, so let's just follow the guideline to be easier, okay? But I let you know, it doesn't matter, okay? They're both hard to be candidate for you, but if they're together, any one work, okay? Any function work for you. But here, let's still let the trig function to be our u. After class, you can try, oh, if I'm gonna let u equals e to the x, and the trig function should be dv. Give it a try, and you'll get the same results, okay? And then dv will be what? E to the x dx. Okay, all right, so what do we do now? du equals differentiate cosine, negative sin of x dx, integrate e to the x, e to the x. You guys, this step, no problem, right? All right, so equals integration by parts, u times v, okay, which is e to the x cosine x. What you is right, cosine x times e to the x, it's the same thing, okay? Minus v times by du. V times by du. There's a negative sign here, okay? So I'm gonna still write it, okay, as, okay, doesn't matter, okay? Sin of x, this is negative sin of x times by e to the x dx, right? Or you write e to the x in front, it doesn't matter, okay? It doesn't matter. And then this negative become positive. Right, guys? Oh, we have this new integral sin of x times e to the x, or e to the x times sin of x dx. Is this integral simpler than the original integral? Do you think it's simpler? No. And are we able to have, any idea to find the direct antiderivative from this integrand? No. So what should we do? We're going to use integration by parts again. Okay, so if we let u to be our trig function, guys, to be consistent, we have to let u equal sin of x. U is the trig function. To be consistent. Later, if you want to try let u equals e to the x, then you have to let e to the x again to be consistent. Okay, since we choose a trig function to be our u, when we use integration by parts, be consistent with it, okay? So that u equals sin of x, and dv equals what? E to the x dx. So let's see what we have. du equals what? Cosine x dx, v equals what? E to the x. You guys, now this equals e to the x cosine x plus, okay? Because this one I'm gonna use integration by parts, I'm gonna use a parenthesis, okay? U times v, which is what? E to the x times sin of x, okay? Okay. Minus what? Integral of v times by du. Okay, v times by du. You guys? Oh, you're gonna ask, oh my God, we want to come with the integral of e to the x cosine x, but we have another e to the x cosine x. What should we do now? There seems like there's endless, right? If we keep on, oh, let's do this like integration by parts, we'll have this. And then once we use integration by parts to that, we have this again. So that doesn't mean that, does that mean we're not able to do the integration? No. Yes, we do have a way to do it, okay? How? Okay, I'm gonna tell you, okay? This is very interesting, okay? So let's simplify this, clear out the parentheses, and give us e to the x cosine x plus e to the x sin of x, and minus what? Integral e to the x cosine x dx. Okay, but what is the left-hand side? Left-hand side is integral of e to the x cosine x dx. What is the right side? This, right? Do you see this integral and this integral repeats? They repeat, right? So since they're repeating, they're like terms. Can we combine the like terms? By moving the negative, this integral to the other side, it gives us what? Twice. Do you see that? So we're gonna have, okay, we'll add this integral from both sides, or move the negative this term to the other side. It gives us what? 2 times, if I let this is our I, this integral is I. Okay. So actually, we're gonna have what? If we move the negative I to the other side, it gives us 2 times by I. Okay. So I would say 2 times I equals e to the x cosine x plus e to the x sin of x, right? We're looking for I. So what do? Divide by 2 from both sides, right? So what is I? This integral. So you may say, oh, this integral equals what? E to the x cosine x plus e to the x sin of x over 2. Yeah, this is a hard question, okay, because we're never encountering, oh, a trig times exponential. Okay. Are you ready to do the next question? And then from this question, you also have to know that, oh, sometimes if 1 times of integration by parts doesn't work, we have to do it a second time. And for exponential times trig, a lot of times we have to let the entire integral to be an I. Okay, I is the integral for short, initial of integral, okay, I. And then we have to use some algebraic way to solve for the integral, right? All right, are you ready to practice this number I? It is hard. So let's talk about this question. Trig involving exponential. Which function do you want it to be u? They both could be u, okay? Exponential function could be u, sin function could be u, okay? But let's make it, you know, the things more straightforward, more easier. Since we know on the list, okay, you know that trig is before exponential, right? Trig is before exponential. So let u equals trig. And then dv equals what? Theta. This question actually is very similar to the previous question, but the only different thing is what? There are some coefficient of the variable theta. Okay, so let's do this question kind of quickly because you know the previous question, okay? So if u equals sin theta, dv equals e to the 2 theta, so how about derivative of u? Sin 2 3 theta. Derivative? Yeah. 3 cosine 3 theta d theta. Do you agree with me? If I make mistake, let me know, okay? I sometimes, you know, do something wrong, okay? I do, okay? So correct me if I say or write something wrong, okay? 3 cosine 3 theta d theta. How about the antiderivative for e to the 2 theta? Tell me. Anyone? Online? Antiderivative. We don't like this too. Oh, what about 2? First theta, 1/2. 1/2 e to the what? 2 theta. What do you think? Right? Plus constant c. All right. So antiderivative for this is what? Oh, did I forget to do a d theta here? Okay, because sorry, if this is our u, all of the rest, the leftover will be dv. Okay, sorry. So v will equals what? 1/2 e to the 2 theta. All right. Now we're going to use integration by parts. U times v, 1/2, I would say 1/2 e to the 2 theta, sin of 3 theta minus integral of v times du. 1/2 times by 3. 3/2. Oh, e to the 2 theta, cosine of 3 theta, d theta. Right? So this integral and this integral, are they the same? They're not the same, but they are in the same level of complicated, right? So what should we do? Use integration by parts again. Okay, again. Now this time, we're gonna let what? Let u equals what? Cosine 3 theta. dv equals what? E to the 2 theta d theta. Now let's compute du. Cosine 3 theta derivative.
-3 sine 3 theta.
3 theta. Yes, good. Thank you. Yeah, -3 sin 3 theta. And then what is the antiderivative? We just did it for v. Yeah, 1/2 what? E to the 2 theta, right? Same thing. Now use integration by parts again. 1/2 e to the 2 theta, sin of 3 theta. We still copy that. We have nothing else to do with it, so just copy that. And the minus 3/2, we still have to copy that. And then for this integral, integration by parts, u times v. 1/2, oh, okay. 1/2 e to the 2 theta times what? Cosine 3 theta, okay? Am I right? U times v, right? 1/2 e to the 2 theta times cosine 3 theta minus integral of v times by du. Okay, so this is what? -3/2, right here. -3/2 e to the 2 theta sin 3 theta. d theta. Right? All right, we know. Negative become positive. Okay, and then this is the integral we love. E to the 2 theta sin 3 theta. E to 2 theta sin 3 theta. However, we have to clear out the, simplified and then get the coefficient of this integral. Okay, so what I'm gonna do is, this is a -3/2. Okay, so let's distribute. So 1/2 e to the 2 theta sin of 3 theta. Okay, -3/2 times by 1/2. What is it? -3/4 minus 3/2 times by +3/2. What is it? -9/4 integral of e to the 2 theta sin of 3 theta d theta. Did I make any mistake? Let me check. uh, let's see whether I'm on the right track or not. Three. Oh, okay. Yeah, so far so good. Okay, if you find anything different, let me know. Okay. All right. So this integral and then the original integral, we can let it to be I. So this is I equals. Okay, this I equals all of this. Okay, this is I equals this minus 9/4 times by I. Okay, so I equals this. We want to solve for I. What should we do? We move the 9/4 times by I to the other side. It will give us what? It will give us the 1 plus 9/4 times I equals, do you agree with me? Yeah, move this to the other side. The other side is just I. Okay, the 1 plus 9/4 times I equals this, right? This. If you want to pull the e to the 2 theta out, yes, you can do, or you can just leave the e to the 2 theta in a regular line. Okay, so I would say just leave that. Okay, so I would say 1/2 e to the 2 theta sin 3 theta minus 3/4 e to 2 theta cosine 3 theta. Right? What is 1 plus 9/4? What is this coefficient?
13/4.
13/4. Okay, so this is 13/4. This is 13/4. Okay. So in order to isolate I, what should we do? We should multiply what? 4/13 from both sides. Okay. So I will equals 4/13. Okay. Because if we multiply 4/13, this cancels out with 13/4. Okay. Right side, I'm going to have this. 4 out of 13. 1/2 e to the 2 theta sin of 3 theta minus 3/4 e to the 2 theta cosine of 3 theta, right? All right, so we can simplify the coefficient a little bit. So 4 times 13 times 1/2 give us what? 2/13 sin of 3 theta. 4/13 times by negative 3/4 minus 3/13 cosine 3 theta, and then e to the what? 2 theta. Or you can keep the e to the 2 theta there. Or you can rewrite this by what? 2 sin 3 theta minus 3 cosine theta times by e to 2 theta divided by 13. Either way, okay, either way. Let me check whether I did this question right or wrong. Yes, I do. Yeah, we're right. Okay, we're right. Right? Say, or you can like this, either way, right? So what do you feel about this question? I feel this question is the most difficult question for this entire section, right? When we involving two hard type of the question, the functions, trig and exponential, 2 times of the integration by parts. Okay. All right. So this is page 3. Okay. So these are the different types. Okay. And then page 4. We have another 15 minutes. So I want to make sure that I cover every important part. Okay. And then if we don't have time to practice in class, I would like you guys to practice in class. And the next class, at the beginning of next class, I will go over the question. Okay. So those questions that if we don't have time to do them in class, take home. At the beginning of next class, check with the answer key. Okay. I'll check. Okay. All right. So yeah, I don't think we have enough time. Oh, we'll see, okay? For all of those previous questions we did were what? That indefinite integral. How about for definite integrals? How can we, do we still have integration by parts? Yes, we do, okay? So definite integral from a to b, f times by g prime dx, okay? So we're still gonna let this is u, this is dv, okay? So by integration by parts, we're gonna have what? u times by v. Okay, however, because it's a definite integral, so once we have u times v, we have to evaluate this what? Product u times v from a to b by evaluation theorem, okay? And then minus the integral, definite integral for what? This is v times by what? du. Same formula, but make sure we do it in a way as what? Definite integral. Well, especially here, don't forget to evaluate this part. And then make sure that your result for a definite integral must be a constant. It's not a function, a family of function. It must be some specific number eventually for definite integral. Okay. All right. So I would say let's try both of the questions together, A and B. Okay. So evaluate it from 0 to 1, inverse tangent x dx. Oh, inverse trick. See on the list, inverse trick is kind of in the front, okay, for our u. So after log is going to be inverse trick, then polynomials, then trig function, then exponential, right? So here, what function do you want it to be u? We don't have a choice. Do we have a choice? No. U has to be inverse tangent x. So the dv will be what? dx. All right, differentiate u. What is a derivative of inverse tangent? Do you know? Do you remember? If no, check the table, okay? Inverse tangent, what is a derivative? Anyone know? 1 over?
Square root 1 plus x.
Close, 1 over 1 plus x squared. Or 1 over x squared plus 1, either way, okay? So I would say 1 over 1 plus x squared, or you say 1 over x squared plus 1. What? Yeah, yeah. The antiderivative for 1 over 1 plus x squared is inverse tangent of x. Yeah. All right, so, oh, this is dx, okay? Yeah, du dx, okay, yeah, something times dx. And then v antiderivative is just x, right? Now let's see, by integration by parts, okay, u times v, x times inverse tangent of x minus integral of v times by du. What is v? X times by that, right? dx. Okay, thing is, yeah, this is minus v times u. But can we just leave this line there? No. For definite integral, we always have to evaluate. See, this is u times v, right? We have to evaluate this thing from 0 to 1. Also for the integral, it has to be a definite integral from 0 to 1. Okay, so now for evaluation theorem, when x equals 1, we should have 1 times what? Inverse of 1, inverse tangent of 1, right? And then minus what? When x equals 0, 0 times of anything 0, minus by 0, yeah, minus by 0. Okay. And then for this definite integral, x dx over 1 plus x squared, how can we compute this definite integral? We just learned, so far we learned how many techniques? 2, substitution, integration by parts. 1 plus x squared, x over 1 plus x squared, we don't know. But can we use substitution rule? Give it a try. Let's give it a try, okay? So we're gonna let, oh, every time it is u, right? Too many u. But yeah, let's still use the u, okay? Or if you want to use a different, letter, you can use w or something else, okay? So I'm gonna use w this time. You can still use u. I'm gonna let w equals 1 plus x squared. because we don't want to, you know, to do 1 over 1 plus x squared. What is antiderivative? It's hard to know. But 1 over w is w next to the -1. We may be able to find the antiderivative, right? So that w equals 1 plus x squared. So substitution, dw equals what? 2x dx. Let's see what we can rewrite this definite integral. Minus what? Integral. 1 plus w, 1 plus x squared is what? W, right? How about x dx? What is x dx? X dx will be what? dw over 2, right? And 1/2 dw, right? 1/2 dw. This is 1 over w dw. How about the limits? This is the limits for x. We need the limits for w. It should be what? When x equals 0, w equals what? 1. Yes. When x equals what? 1, w should equals what? 1 plus 1 squared
2.
is what? 2. Yes. Okay, so inverse tangent of 1. Do you understand the meaning for inverse tangent of 1? It means tangent of what angle equals 1? Tangent of which angle equals 1? Do you remember? Pi force, right? Tangent pi force equals 1. So inverse tangent of 1 equals pi force, okay? So this is pi force. Minus 0, I'm not gonna, write that, okay? What is antiderivative for 1 over w, dw? Right, you guys? Antiderivative for 1 over w is Ln, absolute value of w. But don't forget to evaluate this from what? 1 to 2. Right? So actually we're gonna have what? 1 over 4 minus 1/2 parenthesis. Evaluate. Ln 2, right? Minus what? Ln 1. What is Ln 1? 0, right? 0. So eventually answer is going to be what? Pi force minus 1/2 times by what? Ln 2. Right, guys? Everyone? Okay, see? For definite integral, by using integration by parts, okay, we have to evaluate the u times v. Also, we have to do a what? Definite integral for the v times by du. Okay, and see, do you think this result is a function of x or it's a specific number? Specific number. Okay, all right, so I don't think we have question to do the entire question B, but I just want to give you a hint, and then you can take this question home as practice, okay? So this integral, which function do you want it to be u? Polynomial times by exponential. Yes, good, okay. So this question, we're gonna let u equals x squared plus 1. And then we're gonna let dv equals what? E to the negative x dx. Okay, so you are going to differentiate this and integrate that. Careful, this is negative x, okay? Yeah, be careful when you do the, find the antiderivative, okay? And then by using integration by parts together with definite integral, practice at home, okay? So next Monday, okay, at the beginning of the class, what I'm gonna do is to show you the key directly, okay? Because next week we still have to do some other new sections, okay? I probably will use the first 10 or 15 minutes to provide you with a key, okay? Or if next Monday the class is too tight, I will write down the key on the notes and send you guys the key for these questions. That also works, right? If I don't think we have time in class to go over these questions. Either way, okay? However, I'm not gonna show you the key right away. You're gonna take this question home as part of your homework assignment, except for the online ones, okay? You do these, okay? And then I will provide you the key in a later time. Either way, okay? Either in class or I will just say, check the email. The answer key is provided, okay? All right, guys, let's call it a day. Please go ahead to do your homework assignments, okay? There's one person who have not enrolled into the WebAssign homework assignments website yet. Please do so as soon as possible, okay? And as I said, okay, exam 2 will be available very soon, okay? So I will let you guys know when you can start to schedule to take your exam 1, okay? Exam 1, not exam 2, okay? Exam 1. All right, guys, let's call it. I'll see you next week, okay? All right.